Okay, this is kvpy 2018 paper SB. Maybe beginning questions are somewhat easier. Okay, I'm sure some of the answers you might have got already. But one thing is, at least those are attending, I want you to at least read the questions before the class, think for a few minutes and come. Whether you got the answer or not, secondary. You should have read. There are different ways to do it. I want you to remind of one theorem called Cayley-Hamilton theorem. Even in the this year JEE Advanced 2020 also, there's a question that was given. If you use Cayley-Hamilton theorem, it is easy. Without that also, we can do it. One may say, what is this Cayley-Hamilton theorem? You take any square matrix A. Okay. Take A minus lambda I, the determinant equal to 0. When you expand it, you will get a polynomial in terms of lambda. If it is a 2 by 2 matrix, you may get lambda square minus something into lambda plus something equal to 0. If it is a 3 by 3 matrix, you will get minus lambda cube plus lambda square into something, minus lambda into something. I can take plus also, not a problem. This equation is called characteristic equation of matrix A. So whenever you take a matrix A, subtract lambda, take the det equal to 0, you'll get a polynomial in terms of lambda. That is called characteristic equation of matrix A. Now, in the place of lambda, when you substitute A, it will satisfy. That is called Cayley-Hamilton theorem. You take the characteristic equation, wherever lambda is there, you substitute A, matrix A, it will satisfy. It is not a proper explanation, just to have a feeling of that. In the place of lambda, substitute A here. You will get A minus AI. But A into I is A only. A into A is null matrix and determinant of null matrix is 0. So one may say matrix A will definitely satisfy this. But lambda is a number, but in the place of number, we are substituting a matrix. So how will you justify that? There's a proper explanation that you study in MSc or BSc. Right now, we are not, this is not there in a official way in syllabus for JEE Advanced Mains, but knowing it helps. Okay, so I'm only making 2 points. You take a square matrix, subtract lambda, take that equal to 0, you'll get a polynomial that is called characteristic equation. In the place of lambda, substitute matrix A. For example, let us say somebody got lambda square minus 6 lambda plus 7 equal to 0. When I substitute matrix A, it will become A square minus 6A, and 7 we should take it as 7i equal to 0. Okay, so then we say matrix A is satisfying this equation. Okay, that matrix A will satisfy this equation is called Cayley-Hamilton theorem, which is a characteristic equation. Cubic also, then cubic will come. If A is a 4 by 4 matrix, then 4th degree equation. Is it okay?
So why specifically cube or square?
What cube of square? If A is a n by n matrix, then A minus lambda equal to 0. When you expand, you'll get an nth degree polynomial. Okay, in the place of lambda, you substitute A, then you will know one equation of nth degree where matrix A is satisfying. I'm not saying 2 or 3. In our syllabus, we only deal with 2 or 3. Otherwise, it is true for 5th degree, 10th degree, 100th degree also. Is it okay?
Sir, I didn't understand why to the power of n we should.
Not that we want to power of n, it comes automatically. Okay. If you take this determinant, what will come? If it is a 2 by 2 matrix, you will get some 7 minus lambda here, some 9 minus lambda. When you expand, you will get a quadratic only. If it is a 3 by 3 matrix originally, you will get some 2 minus lambda here, 5 minus lambda here, some 7 minus lambda, some numbers here. When you expand, obviously cubic will come. Is it okay?
Yes.
Now, when you take any nth degree, not a problem. Matrix A will satisfy A power n minus something into A power n minus 1, so on, some constant equal to 0. You will always find the sum of the roots of this will come trace. What you get here will be trace minus of trace. And what you get here will be the determinant of the matrix. Of course, this y determinant will come quite easily, you can understand. When you put lambda 0, what happens?
Mod A equal to 0.
Oh, no, 0 is not there. Det of A minus lambda is equal to this, right? Now, when you put lambda equal to 0, then this will be what you call that A. And here, when you put that lambda everywhere 0, okay, this is not A now, lambda, will also get that. Of course, whether the coefficient is minus or plus, it matters whether you get plus that or minus that. So I'll tell you, for a 2 by 2 matrix will satisfy what kind of equation? Let us look at that. I can do this question in some other way. I'm just using this question as an excuse to explain about Cayley-Hamilton theorem. Okay. You take matrix A is equal to A, B, C, D. Let us take A minus lambda I, which is A, B, C, D, lambda 0, 0, lambda. I'll get A minus lambda, B, C, D minus lambda. Let us take that of A minus lambda I. That is A minus lambda into D minus lambda minus BC, which is lambda square minus A plus D into lambda plus AD minus BC. So when you take lambda square minus A plus D into lambda plus AD minus BC equal to 0, this is called characteristic equation of this matrix. And in the place of lambda, when you substitute A square minus A plus D into A plus AD minus BC into I will be null matrix. Matrix A will satisfy this. Putting in the place of lambda A, that is Cayley-Hamilton theorem. Okay. Now, if you see carefully what you got here, trace. What you got here, determinant. If somebody says, yeah. If somebody says matrix A will satisfy A square minus 6A plus 7I equal to null matrix, and A is a 2 by 2 matrix, what I can conclude now?
Trace
Trace
is
is 6, determinant is
Trace is 6, is determinant is 7. Okay.
hit the points.
If somebody says A square minus 5A equal to null matrix, that's all. Then,
Determinant is 0.
and trace is 5. If A square minus A is equal to null matrix, then
Determinant is 0 and trace is 1.
1. That is our present question, by the way. What is the question? They gave a matrix. They already said AD minus BC is 0. And they said A square equal to A. Bring A to the LHS, you'll get A square minus A equal to null matrix. They asked what is A plus D, which is exactly trace. So trace is 1. Is it all right?
Sir, no, sir. Did not
Why?
understand.
Not understood. Look at this. Look at the screen, not the
Yes.
question. Look at the board, I'm saying. Okay. Look at the board. When they, what else they gave, the A square minus A equal to null matrix. But we know every 2 by 2 matrix will satisfy this. So when you compare, in the place of A plus D, 1 is there. So trace is 1. And AD minus BC into I is not even there. So AD minus BC is null, 0. Is it okay?
Now, means the trace word is there. No, sir. I did not catch that, sir. That's why.
Yeah, okay, fine. Yeah, but of course, there is some little exception which will be there is sometimes a 2 by 2 matrix need not have to satisfy quadratic. It can satisfy a linear only. For example, identity matrix also will satisfy this. I square equal to I. But for that, determinant is not 0, right? Yeah. So then what happens? For A equal to I, you don't have to go to quadratic equation. Directly A minus I equal to 0 itself is the equation. If identity matrix will satisfy something of this sort, we'll get A square minus 2A plus I equal to null matrix, which is a perfect square. Yeah, so there are some exceptions with not exceptions. When you have a repeated root, it will come like that basically. When a characteristic equation has a repeated root, then some things have to be violated here. Okay, we'll come there. But one thing, because they already said that what is that? Determinant is 0, you can easily compare this and this. One may say, I don't want to use Cayley-Hamilton theorem, I just want to do normally. Let us do that. Okay. So if we take A equal to ABCD, let us really find A square, what will come? ABCD into ABCD, which is A square plus BC, B times A plus D, C times A plus D, and BC plus D square. That should be A according to the question, which is ABC. Okay. Now when you equate, you will get A square plus BC equal to A1 equation, B times A plus D equal to B1 equation, C times A plus D equal to C1 equation, BC plus D square equal to D1 equation. From these two, either you can say B equal to C equal to 0, or you can say A plus D equal to 1. One of them must be. Why? If you take B common, you either will get B into A plus D minus 1 equal to 0. Either B is 0 or A plus D minus 1 is 0. Okay. So that is A plus D is 1. When A plus D is 1, S, B equal to B, C equal to C. If A plus D is not 1, okay. But in the question they said non-zero element, so I cannot take this. So I have to take this. It is not a difficult question. You don't have to go for Cayley-Hamilton theorem and all that. Okay. If you know Cayley-Hamilton theorem and you remember that A square minus A plus D into A plus all that, just by looking you can tell. That's my intention of telling all that and to get reminding you of that theorem. Otherwise, simply find A square equated to A. You got two cases because they said in the question non-zero elements. We just take this. We did not even use as such AD minus BC is 0. Okay. Is it all right? First question.
Yes, sir.
So,
Okay, the second question, the statement I did not like it. In the options, they were talking about roots of unity, but they did not tell which roots are square roots, cube roots. I think they're talking about all kinds of nth roots of unity. They can be 20th roots, 100th roots, and so on. I'm sure that is fairly simple. If you take mod z equal to 1, unit circle, nth roots of unity, if you take cube roots, one will be here, one will be here, one will be here. This is about complex numbers. So if you don't know about complex numbers, just listen, don't worry about understand. If you take fourth roots of unity, you'll get here. If you take fifth roots of unity, you'll get one here, one here, one here, one here, like that. And you go to 100th roots, 1000 roots, 10,000 roots, I'm sure they'll be at equidistant at 10,000. So when you take a small piece, however small it is, okay, very small piece of the R, 1,000, let us say this, how much angle it subtends, you take that, okay. I want it to be 2 pi by n. Let's say when it is roughly 2 pi by n and n is, let us say, km 10,000. So when I take 9,000 roots of unity, I may not get one will be here, one will be here maybe. But when I take 1 lakh, 10 lakh roots of unity, they will be lying. Okay. So however small angle you take theta here, definitely I can find some 2 pi by n where my n is, this should be smaller than this. So my n will be bigger than 2 pi by theta. I can find it. Always there an integer exists. So option D, there are infinitely many roots of unity which will lie in that as you increase the n value. Those who know about complex numbers, have you understood this part, what I'm saying?
Yes, sir.
Yes, sir.
Okay. So which is a fairly simple one, I think difficult. Okay. Third one is also not very difficult. It's a very simple routine question that we do. So every day we'll not be able to discuss too many, whatever is possible in half an hour. But what happens is when we do some questions, we'll get a small doubt in a particular chapter. We'll go back and read that chapter. So in the process of discussing the paper, I'm sure most of the topics or concepts will be covered. We'll go back and see what is continuity ones, what is differentiability ones, what is some limits ones, some ellipse formulas. Okay. So in that way you are revising. Okay. I have an ellipse and they gave 4 symmetrical points here. 3 cos theta comma 2 sin theta is the general point. A cos theta comma b sin theta minus a cos theta comma b sin theta, minus a cos theta minus b sin theta, like this. If I take tangent here, tangent here, tangent here, tangent here, they definitely form a rhombus. It's a quadrilateral, but they form a rhombus. I want that area to be greatest. In fact, I can only find this area, and 4 times that will be this total area. And I want to find a minimum because maximum is obviously infinity. When you take a tangent like this, practically it will be infinity. Anyway, the general tangent is x cos theta by a plus y sin theta by b equal to 1. At this s1 equal to 0 when you do it. You will get x cos theta by 3 plus y sin theta by 2 is equal to 1. What is the x-intercept at this point? 3 by cos theta comma 0. What is this point? 0 comma 2 by sin theta. What is the area of this OAB? And our required area is 4 times triangle OAB. 4 times half into base is 3 by cos theta and height is 2 by sin theta. 2 will cancel, or you can keep the 2. 24 by sin 2 theta. So this area as theta changes is always 24 by sin 2 theta. Yeah. So we took the ellipse, 4 points which are symmetrical. At this point, when you do S1 equal to 0, you'll get the standard tangent x cos theta by a plus y sin theta by b equal to 1. X-intercept and y-intercept are this and this. The area of this triangle is half into base into height, 4 times that is the total quadrilateral area rhombus. We'll get this. If you want it to be minimum, denominator should be maximum, which is 24 by 1, which will be 20. Is it okay? Third question. Not very complicated question, just a straightforward formula, right? Anybody has not understood? People are not responding, that's why I'm asking.
Understood.
Understood. Okay. Okay, fourth one, which is on the screen. Before even solving the question, can somebody tell me cos x plus cos root 2x, what is the maximum value? Cos x alone, what is the maximum value?
1, sir.
1.
Cos root 2x, what is the maximum value? 1. So the total maximum value will be 1 plus 1, which is equal to 2. And is there any x value for which it is attained?
Sir, 0.
0.
0. Is this total a periodic function?
No, sir.
Yes.
Cos x alone is periodic?
Yes, sir.
Cos root 2x alone is periodic?
Yes, sir.
When
Yes.
you add two periodic functions, it will be periodic?
Yes.
No, need not be.
Sir, not periodic.
Because LCM will not exist if it is periodic. Okay. So don't think when two functions are periodic, their sum must be periodic. No. If it is that, if 0 is a solution, keep on adding 2 pi also should be solution. If you say period is 2 pi, but there is no period for this. Why it is not? What is the period for this 2 pi? What is the period for this 2 pi by root 2, which is root 2 pi? What are the other periods of this? 4 pi, 6 pi, 8 pi, so on. What are the other periods of this? 2 times root 2 pi, 3 times root 2 pi, 4 times root 2 pi. No multiple of this can match with a multiple of this. So there is no common multiple. So there is no LCM for these two. Integer multiple of this. When you say LCM, you are talking about integer multiple of this have a common multiple. So please understand this is periodic, but their sum is not periodic. If it would have been periodic, if it attains 2 at one point, it will attain value 2 at many other points also, but it is not that. Okay. So cos x alone maximum value is 1. Cos root 2x alone maximum value is 1. Total maximum value is 2. And that is attained only at x equal to 0. At other places where it is attained, for the first one where it becomes 1 is 2 pi, 4 pi, 6 pi. For second one where it is attained is root 2 pi, 2 root 2 pi, 3 root 2 pi. There is no common element where again they can attain the same one simultaneously. So only at 0 it is 2, everywhere else it is less than 2. So that is exactly the question. So what is the question? Set of all values of x for which cos x plus cos root x is less than 2. Yes, except 0, everything else is fine, which is option D. Is it okay, fourth one?
Yes, sir.
Okay. So there is a periodicity concept that is involved, that one should not think there are infinite solutions. And another is the maximum value for each you should know, and that too they're happening simultaneously at 0. Okay, fifth question. Let us read it. Okay, so I think I have a hyperbola like this, and one point is minus a comma 0, and I think I should take 2 points on the other branch of the hyperbola and then get an equivalent triangle here. A is minus a comma 0. P and C are symmetrically placed with respect to x-axis on the branch of hyperbola not containing a triangle which is equilateral. Then what is the length of the side? Okay, is Ka. Then this is Ka and this angle is 30, this angle is 30, this is Ka cos 30, this is Ka sin 30. So according to parametric form, what are the coordinates of B? I can tell. So this is minus a comma 0. This is x square minus y square equal to a square. This point according to parametric form is minus a plus Ka cos 30, 0 plus Ka sin 30. Okay, x1, y1 r theta, x1 plus r cos theta, y1 plus r sin theta. That point should satisfy this hyperbola. What is x coordinate? Minus a plus cos 30 is root 3 by 2, Ka root 3 by 2 whole square. Y square Ka by 2 whole square equal to a square. Okay, everywhere a square will go. I can take LCM also. I'll get minus 2 plus k root 3 whole square minus k whole square equal to 2 square. And I multiply 2 square everywhere. 3k square minus 4 root 3k plus 4 minus k square equal to 4. Now constant is getting cancelled, so it is not a quadratic also. No quadratic, but will get easy. So 4 and 4 when you cancel, and we'll get 2k square minus 4 root 3k 0. So k equal to 2 root 3. So you're able to get exact value, which is root 12, which is between 3 and 4. Which is between 2 and 4, option B. It's not definitely more than. Is it okay, fifth one?
Sir, how did we get that B point, sir?
How did you get point B? Parametric form. If I have a line where one point is x1, y1, this angle is theta at a distance r. If there is a point, what is that? x1 plus r cos theta, y1 plus r sin theta, right?
Yes, sir.
Okay. So in the same way, this is minus a comma 0. This angle is 30 because total is 60, 30, 30. And this length is Ka. This is like x1, y1. This is theta. This is r. x1 plus r cos theta, y1 plus r sin theta. Is it okay?
Yes, sir. Yes, sir.
Anybody else have any doubt regarding fifth one?
No.
Okay. Yeah, quite regularly in JEE mains also I have seen, especially in the 2020 papers, the trigonometric equation questions they gave mostly based on extreme values. You have to find LHS maximum and minimum, RHS maximum and minimum. You will understand LHS is less than equal to 5, RHS is more than greater than equal to 5. The only chance they can be equal is when they're equal to 5. So this particular, and whether they happen simultaneously also or not, you have to check. Coming to this particular question, you can see on the screen itself. Okay, I don't think I have to write on the board. I'll try to annotate there. RHS is, I can say it is always greater than equal to 2. Anybody want to tell why?
Sir, x square means x square plus 1 by x square is always greater than 2.
Yeah, you take something plus the reciprocal if it is positive greater than equal to 2 based on AMJ inequality, right? And in LHS, cos square of something, what is the maximum value?
1, sir.
1. 1 plus x square alone, denominator, what is the minimum value?
0.
1, sir.
1, sir.
1.
1. 1 plus x square minimum is 1. It's a reciprocal, maximum is 1. Denominator minimum is 1 means numerator maximum is 1. So LHS, this maximum is 1, this maximum is 1. So total LHS maximum is 1. So LHS is less than or equal to 2, whereas RHS is greater than or equal to 2. The only chance they can be equal is when both are 2. And I don't think it will happen simultaneously. Okay, so we have to prove that also. I'll try to write something about it on the board. If this meeting ends, you just leave. Don't have to rejoin today. If something is left in
Sir,
between, also we'll discuss.
satisfying.
Satisfying. There is an x values. Let us see. Cos square x plus secant square x by 2 is greater than equal to square root of cos square x into secant square x. AMG inequality. A plus b by 2 is greater than equal to root a. Cos square secant square cancel once and to that side. You'll get cos square x plus secant square x is greater than equal to 2. So that is RHS is greater than equal to 2. And equal to 2 will happen when cos x is 1 or cos square x is 1. Oh, it is happening simultaneously, I think. That's okay. Coming to LHS, I did not see something. What is that? Cos of something was there.
Cos square x.
Cos square of x sine 2x. Yeah. Cos square of something is less than or equal to 1 and equal to 1 is attained when x sine 2x is 0 or 2 pi, so on, any multiple of 2 pi. Even pi also okay, because square is 0, pi, 2 pi, so. Next, x square is greater than or equal to 0. 1 plus x square is greater than or equal to 1. When you take reciprocal, 1 by 1 plus x square is greater than, less than or equal to 1. This is less, and 1 by 1 plus x square equal to 1 will happen only at x equal to 0. Okay, this is less than equal to 1. This is less than equal to 1 when I add cos square into x sine 2x plus 1 by 1 plus x square is less than equal to 2. That is LHS is less than or equal to 2. RHS is greater than equal to 2. The only chance they can be equal, because one is less than 2, one is more than 2, is both should be 2. So finally you can conclude LHS must be equal to RHS must be equal to 2. We very well know, sorry if this you are not able to see this. LHS and RHS must be equal to 2. Then only they can be equal. When equality will happen? For this to be maximum, x must be 0. For this to be maximum, x sine 2x must be 0. RHS cos square x must be 1. They're all happening at 0 also. Okay. So when x is 0, everything is matching. So it's fine. There's only one x value where LHS is equal to RHS. Is it all right?
Yes,
Okay.
sir.
Okay. This question is also quite easy, the 7th one. Okay, basically this seventh one is we have an ellipse. This is the length of minor axis. These are the two foci. When you extend it like this, they are meeting at ellipse at P and C, and that is an equilateral triangle. Okay, take ellipse one end of minor axis, join to the two foci. When you extend it, they will meet the ellipse at this. When you join, this is an equilateral triangle. Actually, earlier we had done questions where this is equilateral triangle, but both are same. If you take an equilateral triangle and you cut it anywhere like this, all are equilateral triangles only, right?
Yes,
Whether you
sir.
take this or this or this, all are equilateral triangles. So when you say this angle is 60, this angle is 60, and this total angle is 60, you are saying this is 30, this is 30, this is also 60, 60. And I told you cos of this angle will give you eccentricity, just one step only. Why? This length is AE, this length is B. Everybody knows. But what about this length? Only up to here, F1. Anybody remembers what is this length? That will be A. Why? Root over AE whole square plus B square. We know, yeah, what is that? B square equal to A square minus A square E square. If you bring this side, B square plus A square E square equal to A square. There's a Pythagorean triad. This is B, this is AE, and this is A. Another thing is, to take any point on the ellipse, sum of the focal distance should be 2A. At this point, they're equal, so this is A, this is A. Now, what is the advantage? If this is theta, whenever you take cos theta, adjacent side is AE and hypotenuse is E, which is equal to E. And here theta is 60. So cos 60 is equal to E. So E is 1 by 2. Okay. Even though it is a simple point, this is A. So through this question, we just got reminded of that. Is it all right?
Yes, sir.
Okay. I really don't have to find this length, equate it, and somehow find eccentricity and all that. So it always, there are many questions in ellipse about eccentricity. Most of them can be done, provided you just know from the minor axis to vertex when you join, if you know this angle, cos of this angle is eccentricity. If you know this angle, sine of that angle is eccentricity. That's it. Okay. I don't know whether I can finish this 7th, 8th question in this time, but let me start. Otherwise, I'll repeat once again tomorrow. So when class ends, don't worry. In between, tomorrow I'll restart again the same solution. If I take cos 2 degree or 3 degree and all, they will satisfy one polynomial I want to show or I want to find what it is. Okay. Instead of 1 degree, let me take cos 6 degrees will satisfy one polynomial, maybe 10th degree equation, 30th degree equation, but I want to find that equation with integer coefficients. Okay. How to find that? Little bit of complex numbers have to be used. I'll take 6 degrees as theta. Then 30 theta is 180. Or I can take 15 theta is 90 degrees. Anything is okay. Cos 30 theta. Of course, I want 0 is better. So I'll take 15 theta is 90 degrees. Cos 15 theta is 0. I'll try to express cos 15